All right, pre-algebra, moving on in chapter 14, talking about adding polynomials today. Now, those of you that really have been able, as we've moved on probably about halfway through the year up until now, have really been able to key in on the idea of how we can and cannot combine like and unlike terms are going to breeze through this, okay? If you struggle with recognizing how to combine like terms, you're going to have to buckle down a little bit more in this section. Adding, and then when we move into subtracting polynomials in the next lesson, the key is that you can only add like terms. So you have to be able to recognize and identify those terms that are like terms. That means they are terms that have the same variables and the variables are raised to the same exponents. And then you have to key in on how to add them, especially if we're adding unlike integers, okay? Or unlike signs, so negative and positive terms. So example number 1, add 3x plus 4 plus 2x minus 6. Now really, the parentheses do not matter because addition is both commutative and associative, which means we can move things around. So really, we can just kind of drop the parentheses here, and we can say 3x plus 4 plus 2x minus 6. Identify your like terms. Here's your x terms, okay? 3x plus 2x, add the numerical coefficients. That becomes 5x. Then we have 4 minus 6 is minus 2. And this is as simple as this expression can get, all right? Because 5x and negative 2 are not like terms because the first term has an x, the second term does not. So that's as simple as we can get that one. Example number 2, we can just drop those parentheses again. Negative 5y plus 9z plus minus y. So that's going to be, you can write that as plus minus y, or you can just write a minus y, and then plus minus 5z is just subtracting 5z. Identify your like terms. Negative 5y minus y. Remember, there's a 1 there. So that's negative 5 minus 1 gives us negative 6y. And then we have a positive 9z minus 5z. So negative 6y minus 4z. Plus 4z, because that's positive 9 minus 5. And that is as simple as that expression can be. Skill check number 1, drop the parentheses, 4y plus 5 plus negative 2y, that's the same as subtracting 2y, plus 6. 4y minus 2y gives me positive 2y, 5 plus 6. 2y plus 11, that's as simple as we can make that one. A minus b plus 2 plus 4a minus 3b plus 8. A plus 4a, there's a 1 there, so that's 5a. Negative b, we can write that 1 there just to keep track of it, so that's negative 1b minus 3b gives me a minus 4b. Positive 2 plus 8 gives me 10, and that's as simple as we can make that one. Practice with number 2, and you should get negative 4x plus 3, and number 3, 8x plus y. Moving right along to example number 3, 3x squared minus 10x plus 9 plus negative 8 squared, that's the same as subtracting 8 squared, plus 17x plus 2. Identify your like terms. We have a 3x squared and a minus 8x squared. 3 minus 8, 5x squared. Negative 10x plus a positive 17x. So negative 10 plus 17 gives me a positive 7x. 9 plus 2 plus 11. And that is as simple as we can make that one. Okay, moving along to example number 4. 3a cubed minus 8a minus 9 plus 5a cubed plus 10a squared plus 8. 3a cubed plus 5a cubed, 8a cubed. Only one a squared term, so plus 10a squared. Only one a term, minus 8a minus 9 plus 8, so negative 9 plus 8 gives me a minus 1, and that's as simple as we can make that. Skill check number 2, add these guys together. 4a squared minus 7a squared gives me a negative 3a squared. 3ab minus 10ab gives me a negative 7ab minus 2b squared minus 7b squared gives me a minus 9b squared. I'm going to be a stickler on these because they're pretty straightforward. I want to make sure that you guys are writing your terms in the proper order. So make sure you're writing your terms in descending order of the powers of the variables as well as in alphabetical order. So your A term comes first, your AB comes second, and then your B term comes last. Up in example number 4, your a cubed term, then your a squared term, then your a to the 1 term, and then your nothing or a to the 0 term last. Okay, I am going to be looking for those to be written in the right order. It does matter, especially when we move into algebra. So I want you guys to get into the good habit of doing that now. Skill check number 4 in skill check number 2, 7x cubed. And we have an x cubed termed over here. That's 11x cubed. I've got a 13x here minus 3x over there, so that's 10x. This lonely negative 8x to the 5th plus 9, and I'm going to rewrite this to make sure my terms are in the proper order. And this is as simple as you can make number 4. I'd like you to try and tackle number 1 and number 3. Number 1, you should get x squared minus 8x plus 1. And number 3, you should end up with x to the 4th plus 2x cubed minus 4x squared plus 8x minus 22. That's a long one. Example number 5. Okay, we can also, we've been, in the previous examples here, we've been working with whole numbers or integers, okay? And now we're going to be working with some decimals and some fractions. Same rules apply. Look for your like terms. I'm just going to rewrite this 2.5x squared plus 8 2/10 xy minus 4y squared plus 3y squared minus 4/10 xy minus 1 5/10 y squared. X squared term, that is the only x squared term, so 2.5x squared. 8 2/10 xy minus 4/10 xy, so that gives me 8.2 minus 0.4 is 7 8/10 xy, and then I have minus 4y squared plus 3y squared, so that right there gives me a minus y squared minus 1.5y squared, so that's minus 2.5 y squared. That's as simple as we can make that one. And I'm looking at my example in the book and wondering if I wrote something down incorrectly because I ended up with a different answer. What did I do? All right, I figured out what I did. When I copied this from the book, I wrote this as 3y squared. That should have been 3x squared. So the way that I tackled this, it's correct. The way that I've written the problem here, it's different than the example in your book, but the math is still correct. So you can just go with what I have. Example number 6, we're working with some fractions now. So we have 1/5 x plus 3/10 plus 1/10 x minus 3/5. So we're going to be combining these two x terms. Because they're fractions, we need to have common denominators. So our common denominator is going to be 10. So 1/5 is going to be 2/10 x plus 1/10 x. I'm just going to write these out just so we can keep track of our fractions a little clearer. And then 3/10, we're going to, that's a like term with negative 3/5. Common denominator for those is going to be 10 as well. 3/10 minus 3/5 becomes, 5 goes into 10, 2 times 3 is 6. So now we have 2/10 x plus 1/10 x gives me 3/10 x plus 3/10 minus 6/10. So 3 minus 6 gives me 3/10 x minus 3/10. Okay. Your book says you can go ahead and simplify that to decimals. I'd rather you not. I'd rather you just leave it in fractional form. Just make sure your fractions are in lowest terms. Skill check number 3. We're again looking for like terms. So here I have an x squared y term, and here I have an x squared y term. So 12 plus 16 is 28 x squared y. Since I have so much going on in this problem, I'm just going to cross out my like terms as I work through it so I don't lose track of anything. Then I have xy terms, negative 13xy and 2xy. So negative 13 plus 2 gives me negative 11xy. And then I have xy squared terms, and I have negative 4xy squared plus positive 4xy squared. Negative 4 plus 4 is 0. 0 times xy squared would just be 0. So that term with the xy squared just completely goes away. And we end up with 28x squared y minus 11xy. That's as simple as possible. Number 4, 2.5x squared plus 3x squared. So 5.5x squared. Next, we look at our xy terms. Negative 7xy plus 2xy, negative 7 plus 2, negative 5xy. Those go away. And lastly, 4/10 y squared and 1 6/10 y squared. 4/10 plus 1 6/10 is 2 y squared. That is as simple as that one can be. Challenge yourself to do number 1 and number 2 for practice. Number 1 gives you 3/4 x minus 3y. And number 2 gives you 4.5x squared plus 2.4x plus 2. I think that's the end of this lesson. Yep.